Hi guys, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Leetcode Weekly Contest 432. So I hope you all had a great contest. In this PCD, we will discuss the first three problems of the contest and try to understand their solutions. I hope you all will learn a lot from it. So let's begin. Okay, so this is the first problem of the contest. The name of the problem is Zigzag Grid Traversal with Skip. It says that you are given an m cross n 2D array grid of positive integers. Great. Your task is to traverse grid in a zigzag pattern while skipping every alternate cell. Okay, so what does a zigzag pattern mean? Zigzag pattern traversal is defined as following the below actions. So start at the top left cell 0, 0. Move right within a row until the end of the row is reached. Drop down to the next row, then traverse left until the beginning of the row is reached. And then continue alternating between the right and left traversal until every row has been traversed. Great. Note that you must skip every alternate cell during the traversal. Return an array of integers result containing in order the value of the cells visited during the zigzag traversal with skips. Okay, and here there are some example test cases. So let me explain what does the problem actually asks for. So the problem says that in input, so the input to the problem is an m cross n grid. Great. And what is the output of the problem? The output which is asked for us to give is basically a zigzag traversal of this grid. Okay, great. So first of all, I think just reading the problem statement, you must understand that this is just a problem which requires an intelligent type of iteration over the grid and nothing else. So there is no hard logic behind the problem. So just for the sake of some concreteness, let me draw a few examples. So suppose this is my grid. So I have a 1, I have a 2, I have a 3 here, and I have a 4 here. Great. So suppose this is my grid. Now what should be the output? First of all, you have to understand what does a zigzag traversal mean. The question says that a zigzag traversal basically means that you need to start from this cell 0, 0. You need to keep going right and right, and then once you reach the end of this row, you have to go left in the next row itself. So if I do not skip anything, say I do not skip anything, so what values do I get? If I do not skip anything, the values I get in this order is basically 1, 2, 3, sorry, it should be 1, 2, then a 4 and then a 3, right? Because in a zigzag traversal, we first go right and then we come down and then we go left. Then again we come down and then again we go right, and we keep on alternating between these directions. So if I do not skip anything, this should be my array, right? But the question says that you have to skip every alternate cell. So that means it is the demand of the question that you need to skip alternate cells. So skip this 2 and skip this 3. So what output should you give? The output should be these two integers 1 and 4. You need to return a vector which contains these two integers 1 and 4. Great. Let's understand a few more examples. So I picked this example from the test case already given. So it basically says 1, 2, 3. Okay, let me confirm once. Yeah, so this is the grid we are talking about. So it is 1, 2, 3, then a 4, a 5, a 6, a 7, an 8 and a 9. So suppose this is my grid. So what should happen in a zigzag traversal? It is first here, then it has to go in this direction, then it will come down, then it will keep on going in this direction, then again it will come down and again keep on going in this direction. But while doing so, it will skip every alternate cell in between. So what actually happens is, it is in 1, then it will skip 2 and go to 3. Okay, then it should come down, but it will not come down, it will skip 6 and go to 5 in this path. Then from 5 it will skip 4 and go to 7, and then 7 it will skip 8 and go to 9. So the logic is the same. If you try to find the logic, it is exactly the same. You first find the entire traversal without any alternating and stuff. So if I do not alternate anything, what actually happens? So this is the output array, right? 1 2 3. So this is my initial direction of traversal 1 2 3. Then I go down and now I move towards my left. So then it should be 6 5 4, and then it should be 7 8 9, right? But now the question says that okay, you need to alternate between the cells. You have to delete all the alternating elements from here. So deleted the 2, delete the 6, delete the 4 and delete the 8. So finally the output which you get is basically 1, then a 3, then a 5, then a 7, then a 9. Let me confirm once that whether I have done the dry run right or wrong. Okay, so this is what the output actually asks for, 13579. So I hope that the problem statement and what does the question asks for is clear. Now let me explain the solution. So the solution is pretty straightforward. There is a grid given and we need to traverse the grid in a certain way. And the traversal logic is also not very complicated, right? Now let me tell you that there are multiple ways to solve the problem. So there are just many ways you can implement this. The simplest way I could think of would be just pushing all these vectors and making a linear array of size nm. So this is what I have done. So take this grid, scan this grid. For first take this row 1 2 3, then take the reverse of this row 6 5 4, then take 7 8 9. So see, that is what I have done. You take 1 2 3, then you take the reverse of this 6 5 4, then you take 7 8 9, and then you push all the alternating elements of this array into this array, right? So you just push 1, then 3, 5, 7 and 9. So this is probably an idea which should work, but this will require making an extra memory, right, of size order nm. So the auxiliary space complexity for this code would be order nm. Something smarter can be done. So let me tell you what I have done. You can basically maintain two variables, say row and column. And we know that 0, 0 is always a part of the answer. So start with say row equals 0 and column equals 0. Great. Also maintain one variable for direction. So the direction variable can be +2. +2 indicate that I skip every alternate cell and go right. And -2 indicates that I skip every alternate cell. So I skip every alternate cell and go left. So something like this you can do. You can maintain two variables row and col, and you can maintain this variable direction, which indicates in which direction we are moving. The idea is very simple then. So basically we need to iterate over all rows of the grid, right? So if I have some grid and then there are some rows here, I start with row equals 0 and column equals 0. So I start at this position. This is row equals 0, row equals column equals 0. Then at every step, what do? I just increase my column with the value of dir. So basically at every step, what do? I do column plus equal to direction, right? Since the value of my direction is +2, this will basically ensure that we jump every cell. Now what does it happens when it reaches the end of the grid? When it reaches the end of the grid, I will increase the value of row by 1. I basically go to the next row, and in the next row, now I will traverse from right to left. Okay, so basically in order to do that, I will reset the value of column here and then again try making the traversals. Okay, so how can I reset the value of column? It is something very simple. So let me show you this, what I have actually done. Again, I am saying that there are multiple ways to implement this, and all of them are completely fine. Okay, so suppose here there comes 0, 1, and then finally comes the index n minus 1. So we are doing zero based indexing here. Great. Now my call starts from 0 and then it keeps on moving skipping every alternate cell and moves in the right direction. So remember that when it reaches, when it exceeds the grid, so this is where the grid is up to. When does it exceed the grid? It exceeds the grid when the value of call becomes greater than equal to n, right? Now note that the value of call can either be n, so either it can be in this part or it can be n plus 1, right? It can be in this part. Because we are making jumps of size 2, whenever it exceeds the grid, either it will reach n or it will reach n plus 1, right? These are the only two possible conditions. So when it reaches n or n plus 1, I could simply write my logic as such, so that when it reaches n, in the next step it starts from n minus 1, right? So if it ever reaches n, that basically means that for the next step it has to start at n minus 1, right? Similarly, if it ever reaches n plus 1, that means at the next step it has to start at n minus 2, right? Because think about this, we are alternating at every step. If it reaches n, then basically it had n minus 2 here and then it jumped to n, right? But instead of jumping to n, where should it jump? It should jump at n minus 1 position of the next row. So that is the logic which I have implemented. I think probably it will be more clear if we see the code once. So let me explain the code properly. Okay, here is the code for it. So we are taking grid as the input, and after that m and n are basically size of the grid which we extract, and then answer is a vector where we will store the actual answer and finally return it. I know that the value of grid 0, 0, basically the top left corner, has to be always a part of the answer, so I just push it, and then I maintain these three variables, which is basically the crux of the solution: dir, row and call. So row and call are 0 initially, which indicates that we start from the top left corner, and direction is 2 initially, which basically indicates that we will skip every alternate cell and go right initially. Okay, I hope that's fine. Now we make a while loop which iterates till the value of row is less than m, right? Whenever the value of row exceeds m, that basically means that we have completed traversal of all the rows and we can simply break the loop. Great. At every step, as I said, we will increase the value of call with direction. So this basically indicates that we jump or make a move. Great. And then here comes the 4 cases. I know, okay, suppose it does not hit any of these 4 cases, then we will just do a simple answer.pushback grid row call. So it basically means that we fill that value of the grid into my answer vector. Great. Now, apart from this, there are 4 cases. What are these 4 cases? So as I was explaining, okay, so suppose I'm traversing some row by the same logic, and suppose these are the indices 0 to n minus 1. What basically happens, whenever an overflow happens, the column variable can either be any of these two positions, n or n plus 1, or it can be any of these two positions, right? Minus 1 or minus 2. So whenever it reaches any of these 4 invalid positions, this may happen because suppose it was moving at left, it finally came at 0, and then it makes a jump of 2 steps to the left and goes to minus 2. Or it starts from say 1 and then it makes a jump to minus 1. So these are the only 4 invalid cells where the column variable can reach. And whenever it reaches to any of those, look at what do I do. I first make a row plus plus. This is common for every part. So that basically means that we now need to iterate the next row. Great. Then I reverse the value of direction. This basically means that if I was traversing towards the right, now I have to traverse towards the left and vice versa. Okay, that's fine. And then I reset the value of column. Okay, so look at where do I reset the value of column? So suppose, let me explain one of the cases. So suppose I was going to the right. Suppose I was going to the right and I finally reached here. So I reached at column equal to n. Great. So what does that mean? That means that in the next row, instead of reaching this column equal to n, I should have reached this position, right? In the next row, I should have reached n minus 1. Okay. So what changes should I need to make to this column variable to make it reach to n minus 1 in the next iteration? I should set column equal to n plus 1, isn't it? Why so? Because if I set column equal to n plus 1, and I have already flipped the value of direction, so the value of direction has already became minus 2. So in the next step, basically a column will the value of direction will be added to col, and it will start from n plus 1 minus 2, which is n minus 1. So that is the logic. Whenever column reaches one of the invalid cells, I basically reset the value of column to something such that in the next iteration, after this step is executed, column plus equal to direction, we actually reach to the valid cell where we desired to reach. Okay, great. So after this, when the entire loop breaks, we just return this vector answer as it was required. So I hope it is clear. This was the logic of the problem. It was pretty straightforward. Just a direction of iteration was important, and I hope I could explain you well. Great. So let's start with the next problem. Okay, great. So this was the problem B of the contest. The name of the problem was maximum amount of money robot can earn. Great. So what does the question say? The question says that you are given an m cross n grid. A robot starts at the top left corner of the grid 0, 0 and wants to reach the bottom right corner m minus 1, n minus 1. Okay, great. The robot can move either right or down at any point of time. Great. The grid contains a value coins ij in each cell. Okay. If coins ij greater than equal to 0, the robot gains that many coins. If coins ij less than 0, the robot encounters a robber and the robber steals the absolute value of coins ij coins. Okay. The robot has a special ability to neutralize robbers in at most 2 cells on its path, preventing them from stealing coins in those paths. Okay, the robot's total coins can be negative, and we need to return the maximum profit the robot can gain on the route. Okay, great. So let me explain what does the problem says. Again, as usual, the input of the problem is simply a grid. So the input of the problem is an m cross n grid. Great. And what is the output? The output of the problem is the maximum profit we can make. Okay, fine. So now what does the question say? If you read the question, it says that we basically have a grid. We have a grid of size m cross n. So there are m rows, there are n columns. Okay, that is fine. The main objective of the problem is that I have to start from this top left cell 0, 0 and I have to reach this bottom right cell, which is n minus 1, m minus 1. Okay, great. Now at every intermediate cell in between, so at every cell in between there is some value. So if this is the ith row and jth column, there is some value present in it, which they are calling coins ij. Fine. Now what do we need to do? We need to move from this 0 comma 0 to by some path to n comma m. Great. At every step of the path, either we can go down, either we can go down or we can go right. These are the only two possibilities. So a path must look like something like this, that you go down and then you go right. Fine. So that means we can never move up or left in any path. That is not allowed. I hope that is clear. So during this path, basically we also extract this value coins ij. So this is the value I get when I traverse a path. So if this is a path which I have traversed, I basically get a value equivalent to the sum of all coins ij on this path. Great. So let me tell you what happens using an example. So let us pick an example. Okay, so 0, 1, minus 1, 1, minus 2, 3, 2, minus 3, 4. So let me just write this down. So we have a 0, we have a 1, we have a minus 1, we have a 1, minus 2, 3 and 2, minus 3, 4. Okay, so 1, just a second. Yeah, so we have 0, 1, minus 1. Then we have a 1, minus 2 and then a 3. And then we have a 2. Okay, I guess I'm facing some issue with the pen. And then we have a 2, minus 3, 4. Okay, so suppose this is what is the grid we have. Okay, great. So we need to start from this cell 0 comma 0 and then we have to reach at this cell 4 comma 4. So there can be multiple paths, right? So consider this path, that I first go down, then I go right, then again I go right and then I go down. So what is the value I get from this path? So the value I get from this path is a 0, then a 1, then a minus 2, then a 3 and then a 4. So this is nothing but the sum of all the values in the path you have taken. So just choose a path and then add all the values which you have in the path. So here the value of the path is 6 here. Okay, great. So that means, and the question says to maximize the profit we can have in this path. But then there is a catch. What is the catch? The catch is that the question also mentions that you can actually neutralize some value on the path. So suppose I can neutralize this minus 2 and I wish to not take it. So if I wish that I will not take a minus 2, so basically this value gets erased from our value, and then what we get is actually not 6 but 8. So I hope it is clear that if you neutralize some negative value on the path, then you will get a larger score, right? So it is always better to neutralize negative values from our path. But the question says that we have the ability to do it only 2 times. So look at the question, what does it says? The robot has a special ability to neutralize robbers in at most 2 cells on its path, preventing them from stealing coins in those cells. So that means if I have a path, then I can actually choose 2 negative values from that path and erase them, or choose not to take it in order to maximize my score. So let me actually show you an example to understand how this happens. So let us take that example. Okay, so suppose this is an example which we may take. Suppose we have a 10, then we have a minus 4, then we have a minus 6, then we have a 8, then we have a minus 25, then we have a minus 12, here we have a 4, and then we have a minus 100 here, and then a minus 100 here as well. Okay, great. So what should be the optimal path? There can be many paths, right? One path could be simply like this, that we go entirely right and then we go entirely down. Okay, so let me call this path 1. So let me call this P1. So what should be the score for P1? The score for P1 is simply the sum of its values, right? So 10 plus a minus 4 plus a minus 6 plus a minus 25 plus a minus 12. Great. But during this, the robber has the power to choose any two negative values and remove them. And since the robber wants to maximize the score, it always makes sense to remove the larger negative values, right? That will lead to a larger score. So if we remove this minus 25 and minus 12 from here, so if I remove minus 25 and minus 12 from here, the score which I get from P1 is simply 0. Great. Now let's try choosing a different path. Why not choose a path something like this? We go from 10, then till 4, then 8. Okay, let me use a different color to do this. Okay, so from 10 I went till 4, then I went to 8, then I went to minus 25, and then I came back to 12. And let me call this path as P2. Now what should be the score of P2? So if you look carefully, the score of P2 is 10, then you have a 4, then you have a 8, then you have a minus 25, then you have a minus 12. Now there are at most two positions where you can get rid of. So let's get rid of these two values. If you get rid of these two values, so that basically it means you neutralize these two scores, then the value which you get is simply 10 plus 4 plus 8, which is 22. So we can see that just by choosing a different path, we can actually get different values or different scores from our path. The question says to choose a path such that our score is maximum and return that maximum score. So I hope that the question is clear. Now let us try to construct a solution. What can the solution be? The first hint, so this is something which will come handy in almost all problems which involve grids, where you actually need to move right or down. So whenever you need to move right or down in a grid, the first thing which should come in your mind is DP. So DP actually comes very handy in these type of problems where there is a grid and you need to maximize or minimize some score, and you have to actually, and from I comma j, the values you can go is basically I comma j plus 1 or I plus 1 comma j. That means basically right or down. So there DP comes very handy. Great. So how can we write a DP state here? So whenever we need to construct a dynamic programming solution, so a DP solution must have two components. The first component is, what does the state represent? So what should be the state of my DP solution? And then what are the transitions? And then what are the transitions? It is also important amongst all this to understand what is the base case of the DP state. So if we can somehow write the state, the transitions and the base case, then we will be done with the DP solution. Okay, so let us discuss this one by one. So what state can you think might help? So I think it is pretty straightforward and common that in whenever these type of problems come where grid happens, wherever you are doing DP on a grid, you always need to keep I and j in the state, right? So you need to keep I and j in the state where I comma j represents the cell basically. So here I comma j represents the cell where we are talking about. Great. So let me write this down. So I comma j is basically the coordinate or the position in the grid. But here there is also one more important thing, and that is the power to neutralize stuff. I know that I can actually neutralize any negative value in my path at most 2 times. So I think it is worth remembering how many times have you already done the neutralization stuff. Because if you have suppose you have already done neutralization once, that means you have power to neutralize a cell once again. So basically, let me make one more state in the DP, K, where K represents the number of times you may neutralize a negative value. I hope you understand that this is important, because whenever you are trying to construct a DP state, always try to understand that what are the information which is required to remember. So if you do not, whenever you are trying to find the maximum value from I comma j to the cell n comma m, then if you do not remember how many times you have already done neutralization, then you will not be able to figure out what is the power I have in my hand, how many times can I neutralize it much more once again, right? So it is important to keep this DP state. I hope you understand that the size of this DP state is basically 3nm, right? Because the number of times I may neutralize a value can be simply, so K can be simply 0, 1 or 2, right? The problem does not allow to neutralize a value more than 2 times. So that means K can be of 3 values, 0, 1 and 2, and the and this is there are n comma m different cells in the grid. So the size of the DP table is 3nm, which is order nm itself. So great. So, but what does the state represent? So DP ijk, what does it represent? So DP ijk represents the maximum profit. So what does it represent? It represents the maximum profit I can get by moving from I comma j to n minus 1 comma m minus 1 with neutralization power equal to K. So basically I have a grid here. And then I'm at some state I comma j. So here this is some state I comma j. And from this state I comma j I need to move by some path to n comma m, right? So my DP state is nothing but what is the maximum cost I will get if I start from I comma j and then by some path I move to n minus 1 m minus 1, and my neutralization power is K. So what does neutralization power means? Neutralization power means that how many times on this path can I neutralize a negative value. So if my neutralization power is 0, then that basically means that it is nothing, the cost of a path is nothing but the sum of the values on its path. If my neutralization power is 1, that means the cost of a path is the sum of the values of a path, but then I can neutralize one largely negative value and get a larger cost. So I hope you understand what is the DP state. So if the DP state is clear, let us discuss what is the base case. What is the base case? So whenever you are thinking the base case of a DP, it is always great to think that base case, that case where the answer is very easy to tell. So since you need to find the maximum cost to reach n minus 1 comma m minus 1, why don't set our base case as DP n minus 1 m minus 1 itself. So I say that DP n minus 1 m minus 1, and suppose my neutralization power is 0. If my neutralization power is 0, what should be the value? Then basically you start from n minus 1 comma m minus 1, and then you have to reach to n minus 1 comma m minus 1. So that does not require any traversal. And since the neutralization power is 0, whatever value there is there in coins n minus 1, m minus 1, you have to accept it, right? So whatever the value is there in coins n minus 1, m minus 1, be it positive or negative, since my neutralization value is 0, and I have already started at that position n minus 1, m minus 1 as per my dp state, then basically I have to take that value, nothing else. Okay, so this is my base case. For other values, what is the base case? So basically, what is, okay, just a second. So what is the value of dp n minus 1, m minus 1, 1? So that basically means we start at n minus 1, m minus 1, and we have to stay there. But now I have a power to neutralize one cell. If I have a power to neutralize one cell, that means if coins n minus 1, m minus 1 is negative, I can neutralize that and actually get a value of 0. So don't you think that this should be nothing but max of 0 and coins n minus 1, m minus 1, right? Here, this actually, what does it mean? This means that if coins n minus 1, m minus 1 is positive, then I will simply take it. But if coins n minus 1, m minus 1 is negative, then still I have the power to neutralize one cell. I will neutralize it and then I will get a value of 0. So whichever among these two is larger, I will get that value. I think it is easy to see that this value is same as dp n minus 1, m minus 1, 2, right? Because if I start at n minus 1, m minus 1, and I have the power to neutralize two cells, then basically that power is same as neutralizing one cell, right? Because I will never explore more than one cells. So the value which I get remains the same. So I hope the base case is clear. Now what would be interesting is to write the transitions itself. So let's write the transitions. Okay, great. So I think the transitions are a bit easy to follow, because in almost all problems which require dp on a grid, the transitions are very similar. So suppose I'm at I comma j, then the two cells where I can move to is basically the two cells I can move to is I plus 1 comma j, I plus 1 comma j, and I comma j plus 1, right? Great. So that means what should be what should be my transitions? Just a second. So let me write the transitions. So the transition should be something like that: you have started from dpij, and then you go and then you have a power to neutralize k cells. Okay. So doesn't that mean that there are two things you can do? So this is something like same as the pick and not pick logic. So you can look at as a hint. So this is something like the pick not pick logic. So you can do two things. So the first case is you can choose not to neutralize. So I will not neutralize ij. So if you not neutralize ij, so that means your neutralization power does not reduces. So if your neutralization power does not reduces, so the value of dp ijk is, so first of all you accept the value which you have at I comma j, because you do not neutralize it. So you accept this value coins ij, and then you take the max of your down and up, right? So you take the max of dp I plus 1 j k. This is the value which you get when you move down. So this is the value which you get when you move down. And apart from this, what else value? That is dp I j plus 1 k, isn't it? And this is the value which you get when you basically move right. So this means that what does it happen? Basically, this is the not pick case where you are choosing not to neutralize. If you are not neutralizing, then you have to take whatever value is there at I comma j, and then you have to take the maximum of the two values you get at right and down, right? And note that whatever neutralization power you have at I comma j, the same neutralization power remains at those two states. It does not reduce because you chose not to neutralize it. Now there is one more case where you choose to neutralize it. So now suppose I choose that I will neutralize it. So if I neutralize it, so what should be the value of dp ijk now? First of all, if I am choosing to neutralize it, then I will take max of 0 and coins ij, right? Since I am choosing to neutralize it, that means at this cell, I will pick coins ij whenever it is greater than 0. If it is less than 0, then there is no point in basically choosing it, because we are using our neutralization power there, and we will actually choose 0 here, isn't it? So we will take max of 0 and coins ij from the cell I comma j itself. Apart from that, again we have 2 power to go right and down, and we will take the max of them. So I can go down. So that would be dp I plus 1 j. But now what I have done, I have used my neutralization power once at the cell I comma j. So now I have one less neutralization power. Similarly, if I can also go right, and here also I will have one less neutralization power, isn't it? So this is what is the transitions. So I think we have discussed all components of our dynamic programming solution. We have discussed the base case. We have discussed what does the DP state actually mean, and we have discussed what are the transitions. Let me show you the code. I think the dynamic programming state and the transitions for this problem was quite intuitive. So look what I have done. I have first maintained a DP array. I have kept it global. You can obviously keep it inside the main, and you can make it of size 3 nm. That works. I have extracted the value of n and m. I hope that's clear. Now what do? I have written an iterative DP where I have basically iterated over all possible values of I, j and k. Great. Now look at this is the base case. If I is n minus 1 and j is m minus 1, so that is basically whenever we are at the bottom right corner. See, if we are at the bottom right corner, then there are two possible cases. So either the value of k is 0. If the value of k is 0, that means that we have no neutralization power. We just simply choose coins ij. And if the value of k is greater than 0, then what do? Then we just take dp ijk as maximum of coins ij and 0, right? Because now we can neutralize it here since we have neutralization power of 1. This is exactly same what we have done. Now there are two cases apart from this. One is that coins ij is greater than equal to 0. If coins ij is greater than equal to 0, there is no need to neutralize. So I've just taken down and right, and both the steps I have kept the neutralization power k, and I've taken the maximum of it. If the value of coins ij is less than 0, then that means that we can actually have two choices here. We can choose not to neutralize, and then we can choose to neutralize. If we choose not to neutralize, then what value do we take? We take dp ij plus 1 k. The value of neutralization power does not change, and then we take the actual value of coins ij, whatever is there. But if we choose to neutralize, then what value do we get? If we choose to neutralize, then that basically means since coins ij was less than 0, I have neutralized it, so that does not add up anything to the score, and then we can actually take the values of dp ij plus 1 or dp I plus 1j, but now with one less neutralization power. So I hope that is clear. I have written the transitions maybe a bit differently than what I have explained, but both of them are correct. There are multiple ways to write it, and all are essentially the same thing. It's just writing max using a certain if condition, and that's it. What do I need to return? This is interesting. So what should I return? So if you look at the state, So this is the state I have, dpijk, and it basically says that I have to start from I comma j and I have to reach the final cell n minus 1 comma m minus 1 with neutralization power k. And what is the maximum profit I can get? That is stored in my dpijk, right? Now what does the question ask? The question says that you need to start from 0 comma 0 with a neutralization power of 2, and then you have to reach n minus 1 m minus 1 by some path, and you have to tell me the maximum profit. So don't you think that is stored in dp002, right? Because dp002 basically means the same thing. You start from 0 comma 0 with a neutralization power of 2 and reach n minus 1 comma m minus 1, and that is what it is. I have returned, after the entire dp calculation, I have returned the value of dp002. So I hope that is clear. So now let us move to the third problem of the contest. Give me a second. Okay, so let us start. The question says that minimize the maximum edge weight of graph. It says that you are given two integers n and threshold, as well as a directed weighted graph of n nodes numbered from 0 to n minus 1. Okay, the graph is represented by a 2D integer array edges where edges I indicates that there is an edge going from node AI to node BI with weight WI. I hope that makes sense. You have to remove some edges from this graph, possibly none, so that it satisfies the following conditions. Okay, what should it satisfy? First of all, node 0 must be reachable from all other nodes. Great. The maximum edge weight in the resulting graph is minimized, and each node has at most threshold outgoing edges. Okay. And the question says that return the minimum possible value of the maximum edge weight after removing the necessary edges. If it is impossible for all conditions to be satisfied, return -1. Okay, so let me explain what does the problem statement says. Okay, just give me a second. Okay, so let's begin with the third problem of the contest. It says that you are given two integers n and threshold, as well as a directed weighted graph of n nodes numbered from 0 to n minus 1. Okay, I think so we have read the problem. So let's begin by understanding what does the problem says. So as usual, the problem has said that in input it will give us a weighted directed graph. So it will give us a weighted directed graph. Fine. It will also give us a value threshold. Okay. So it will give us a value threshold. That's completely fine. Now, what does the output it requires? It requires output as the minimum the minimum value of max weight. The minimum value of max weight such that certain conditions are satisfied. So let us try to analyze and get hold of what conditions are satisfied and how can we check them. So let us look at the conditions one by one. What does the first condition says? The first condition says that node 0 must be reachable from all other nodes. So here is the first condition. Node 0 must be reachable from all other nodes. Okay, that's interesting. So let us analyze this one by one. So this is the first condition. It says that node 0 must be reachable from all nodes. How can you check that whether the node 0 is reachable from all other nodes or not? So suppose I have a graph. So I have a graph where there is this node 0, and then there are lot of directed edges coming from lots of nodes, say, and suppose here there are lots of nodes, other nodes in the graph. How will you check that whether node 0 is reachable from all other nodes or not? The brute force idea would be that you pick every node, do a DFS, and find out that whether node 0 is reachable or not. Now you again go at this node, do a DFS or a BFS, and then try to find out, okay, whether 0 is reachable from here or not. And you do it for all nodes. But if you do it for all nodes, what would be the time complexity? So what would be the brute force time complexity? So brute force time complexity would be that you go to all nodes and then do a BFS, right, to find out whether it is whether 0 is reachable from it or not. But since there are n nodes, and brute force and DFS or BFS takes order n time, order n plus m time, so that means it will take order nm complexity, right? So this will be an n square code. And for constraints like this, let us look at what is the constraints of the problem. Okay, so the value of n is 10 to the power 5. So that means an order n square code would not pass, right? Okay, great. So now let us start. So how can we modify the problem? How can we do something so that we can check that, okay, whether 0 is reachable from all nodes or not? Here is an idea. Instead of, so you have a directed graph, right? So instead of checking that from all other nodes, just a second. Yes, so I have this 0 here, and I need to check from all other nodes n1, n2. Suppose these are the other nodes in the graph nk, and I need to check that does there exist a path from n1 to 0? Does there exist a path from n2 to 0? Does there exist a path from nk to 0, right? So we have to check this, but the problem is checking it for all node requires doing a DFS from every node, and that will be n square. So here is an idea or a trick I have, which is actually handy in a lot of problems. So why don't you make the reverse graph? How to make a reverse graph? You basically take the graph, keep its nodes as it is, and reverse all edges. So basically you reverse all edges. This is the directed graph, so you may reverse all edges. If you reverse all edges, and suppose there exists some setup like this, how does the setup looks like? Now you basically have a node 0. You have the same nodes n1 to nk. So you have these same nodes n1 to nk. But now all the paths are directed from 0 to n1 till n2, and it goes till nk, right? So this is something different. So here you start from 0 and all other nodes n1 to nk are visited. So look at here. In the original graph, you actually had to make a lot of DFS in order to check that whether there exists a path from all these nodes to 0 or not. But if you construct the reverse graph, all the paths get reversed, and now what you need to basically check is that whether you can reach to all nodes from 0 or not. So now you do not need to do DFS or BFS from all other nodes. It suffices to do DFS or BFS from 0 itself. Do BFS from 0 or DFS as you wish, or a DFS, and then you basically check that, okay, whether all other nodes are visible or not. You need to do the DFS or BFS only once here in the reverse graph, and that will take order n time. So I hope it is clear. We actually boiled down what does the first approach says and how can we check it in optimal time complexity, that whether 0 is reachable from all other nodes or not. So what we will do actually is we will not do any computation on the graph given, but we will make computations on the reverse graph. We will do a DFS or BFS from the reverse graph from 0, and then we will check, okay, whether all other nodes are reachable from 0 or not. So this is a quick handy idea. Apart from that, let us look at the other conditions. Okay, so this is an objective kind of thing. So let me ignore this for some moment and we will come back to it later on. Let us look at the third part. Each node has at most threshold outgoing edges. So what does it say? It says that in the graph, so whatever graph you have, so you have some nodes n1, n2, dot 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 nk, and in this graph, every graph should have at most threshold number of outgoing edges. Okay, so these all edges go out, suppose. So basically out degree of every node v should be less than equal to threshold. You need to modify the graph in such a way. But note a very important thing. What is the essential idea, or what is the objective we have in our mind? The objective in our mind is that all nodes should be reachable from 0, right? If I need all nodes to be reachable from 0, then that would require just one outgoing edge. If there is one outgoing edge, so I can always throw away all other edges in the graph. So suppose I have n2 here. So I have n2 here, and suppose from n2, from this edge you can reach 0, from this edge you cannot reach 0, and from this edge you can also reach 0. So now, in order to minimize the out degree, I can just throw away this edge. I can also throw away this edge, because I know that this edge is sufficient. This edge is sufficient to reach 0, right? So that means I can always throw other edges of the graph in order to ensure that the out degree of v is 1. And since, look at the value of threshold. The value of threshold is given from 1 to n minus 1. So I know whatever the value of the threshold be given, it is always greater than equal to 1. And I can change or remove edges in the graph so that only one edge is sufficient for every node in order to reach 0. For example, let us take this example which is given as the input. So you have a graph something like this. So let me draw this graph quickly. Okay, just a second. Okay, so here is how the graph looks like. So we have a node 1 here, then we have a node 2, then we have a node 3 here, and it goes from here to here. Okay, so it says that here is some node 4, and it goes to here, and then we have a 0 here, right? Now what my idea is that if you want to just ensure that you need to reach 0 from all nodes, then why not just take one edge and remove all? So I know that there exists from 2 I can take this path and reach 0. Great. From 1 I can take this path and reach 0. From 3 also I can take this path and reach 0. And from 4 also I can take this path and reach 0. So why not remove all other edges? So why not remove this edge? Also remove this edge. If I do this, that means I can always ignore edges in the graph and try to make a new graph, and we can get a new graph where the out degree of every node is at most 1. Look at 1, it has only one outgoing edge. Look at 2, it has only one outgoing edge. Look at 3, it has only one outgoing edge. Even 4 has only one outgoing edge. So that means ensuring the third condition is never an issue. Whatever value of threshold is given, we need to ensure that each node, what does the question say? That we need to, after removing the necessary edges, we need to ensure that each node has at most threshold outgoing edges. So that would be never an issue. I can always remove necessary edges from the graph so that every node has just one outgoing edge, which will be obviously less than equal to threshold. So this is clear. So let us ignore this condition from now, because we understand that this is trivial and this was probably given just to confuse or just to make the problem statement a bit more complicated. Okay, great. So here is what is the objective. The objective is to find the maximum edge weight in the resulting graph is minimized. So what do I need to do? I need to find the value mx. So I need to find, okay, just let me write this down. So my objective is to minimize the max of all weights, minimize the maximum value of weights. So whenever you get this type of question, first of all understand that this is a monotonic property. Why this is a monotonic property? Because if you can ensure that for some value of w, if you can ensure that that if I take all edges of weight less than equal to w, then 0 is reachable from all nodes. Then my 0 is reachable from all nodes. If we can see this, that if I throw away all edges which have weight greater than w and I take only those edges which have weight less than equal to w, then 0 is reachable from all nodes. If that happens, then this also happens from w plus 1. Like this implies this. Because if you throw away all edges of weight greater than w and still 0 is reachable from all nodes, then we are throwing away lesser edges, right? So if this happens, this condition also implies. So if this is true, then this implies that that would be true. So whenever this happens, we say that the monotonicity property holds. So monotonicity holds, that is great. And if monotonicity holds, the first idea which should come in your mind is basically binary search. So the idea which should come in your mind that we can binary search on the answer. I can binary search on the answer. I can basically, what can I do? Suppose, let me look what is the maximum value of weight which we can have as per the problem statement. So the maximum value of, just a second. The maximum value of weight which I can have is 10 to the power 6. Okay, great. So why not choose my value of low as say 0, my high as something 10 to the power 6, so something 1e6 plus 1, for example. And then what do I need to see? Then I basically need to check that for some value wt, if I throw away all edges from the graph which have weight greater than wt, so I basically only pick those edges which have weight less than wt, then is 0 reachable from all nodes? That is my question, right? So any idea how this can be implemented? I think we have already discussed this. This can be simply implemented by doing a BFS, right? We will do a BFS on the reverse graph. So we will do a BFS on the reverse graph. And while doing this, in our check function, so in our check function, suppose it checks that some value of wt is possible or not, or basically is 0 reachable from all nodes if I throw away edges with weight greater than wt, then basically what does that mean? Then that basically means that I need to do a BFS from 0 on the reverse graph, and I need to check all other vertices are reachable or not. But while doing that, I need to throw away edges of weight greater than wt, right? So instead of constructing a new graph, while doing this BFS, I will simply ignore them. And find this condition. So I hope this is clear. The idea is pretty straightforward. The monotonicity property is something which you should observe, and it will come with practice, which gives an idea why binary search should be done. And after, since it is said that we need to do check reachability of 0, an idea of a BFS or DFS should come in your mind. But the trick was that instead of doing BFS from all other nodes and checking whether 0 is reachable or not, why not reverse the graph and do DFS or BFS from 0 itself? That will require doing a BFS only once. So let me show you the code, and probably it will be more clear. So here is the code. So let's look at the code. So this is something which is just reset. So I basically reset the adjacency list. I clear it for the next test case. That is fine. Look at here. I iterate over the edges and I populate the adjacency list. But while doing that, I reverse the edge. I basically, suppose for some edge uv, I basically insert u in the adjacency list of v. That is basically reversing a directed graph. So adj is not the adjacency list of the graph I have been given, but this is the adjacency list of the reverse graph. So I hope this is clear. And this is nothing but the binary search code which we have written. So basically I start with low 0, I start with high as some value 10 to the power 6 plus 1, and I've kept answer as high as that. and then I do a binary search. While doing a binary search, if I find that okay, some value is possible, then I update the answer and look for a lower value. Otherwise, I go for a larger value. If I see that my answer is greater than 1 is 6, then that probably means that okay, 0 is reachable for no nodes in this range, and then we need to return a -1, else we need to return answer. So I hope this part is clear. Okay, great. Now let me explain the most important part of the code, which is the check function. So how is the check function implemented? So here it is. Basically we do BFS from 0 on the reverse graph, as I have said, and then I also pass the WT as the parameter. As I have explained that while doing BFS, I will ignore all edges of weight greater than WT. Great. So now I iterate over all the nodes and I just check that okay, is the distance from 0 of some node equal to infinity? Because that would mean that okay, it is not reachable from 0 itself in the graph, and then we will return false, else we will return true. And apart from this is simple BFS code which I have written. I have taken it from CP algorithms, and you can also have a look at it. This is simply BFS, and I am not explaining it. But what is important is this part, that if I ever find an edge of weight greater than WT, then I do not process it. I just simply continue to the next iteration of the loop and I simply ignore it, because that is how our check function needs to be implemented. So I hope it is clear. Probably you all have understood the solutions. Thank you. This is what I had. If you find any problems from my side or for the PCD, you need to give a feedback. Then a form will be shared with you, and you can give suggestions there. I will look at it. Thank you.